So we're going to talk about what the least cost rule is, also known as the optimal combination of resources. So basically, the least cost rule states that a firm achieves the optimal combination of resources when the marginal product per dollar, so let's go ahead and while we explain this, write down the actual formula for this. The formula is MP for PX equals marginal product of capital over there. So it states that when the least cost rule states that a firm achieves the optimal combination of resources when the marginal product per dollar spent on each input is equal. And this is the formula for it. So basically this can stand for marginal product of labor. This is price of the labor. This is the marginal product of capital, and this is the price of capital right over here. So it's marginal product, and this down here is price. Basically, this way ensures that resources are allocated in a way that minimizes costs while maintaining its output. So let's go ahead and do an example just to show like how you use the least cost rule and like how it works. Okay, so use this example over here. So how much additional output does each resource generate per dollar spent? We'll just do a chart. Number of units. This is going to be MP, and it's going to be between robots and like workers. Okay, and then we have the MP over price, which our price will be like $10. And then let's move on to workers. We have an MP. These are going to be for the workers, and then we have MP over price. So like basically the price of like the work, and this is going to be $5. Okay, so now we have our labels. We're just going to write down. Now our job is to use this formula over here to figure out the marginal product over price for both robots. This is robots over here, so these both are robots, and these both are for workers. These both are for robots. Okay, so how do we calculate that? Is we subtract both these 30 with 20, and that equals to 10, and then 30 divided by 10 is 3, and you just do that all the way down. So like 20 minus this is 10, 20 divided by 10 is 2, and the same thing, 20 divided by 20 is this is 1, and then same thing over here with 5, and you just do 0.5 over here. And then same thing for over on this side, you just calculate this is going to be 5, so 20 divided by 5 is 4, this is going to be 15 divided by 5, is 3, this is going to be 5, 10 divided by 5 is 10, and then 5 divided by 5 is 1. Okay, so here's what we have over here. This is kind of what we have. Now we need to figure out so our budget is going to be, in this scenario, $35. We need to maximize this money depending on our numbers here. So what we have to do is deduct the cost of each selected unit from the budget and repeat the process until the full $35 is going to be spent. So if we look over here with the first worker. So this is the first worker over here. $5 is spent as MP equals 4. So P equals $5. So $5 is spent already. And if we go down the list, $5 is spent. Go here. We have $10 is spent. So as you can see, we have two. So we keep going down. So we have $5, $5. That equals already 10. And if we go back to robots over here, again, the robots cost a different amount of money. It counts $10. So if we do 10, then we have another one over here. We have $10 spent over here. Now we have $15 remaining. If we go back over here to our third worker, we have another $5. And then now we have only $10 remaining. If we go back over here, we have $10, another $10 spent with our second worker. And now we have only $15 remaining. And then if we go back over here to third worker, we have another $5. And now if we go to second robot, we have $10 spent, and then now we finally have $0 remaining. So you just kind of go back and forth until you maximize the budget. So we went from here to here, back here and here. So now we finally have our number. So we went up till second worker for robots, and over here we went up till third worker for the number of workers. So our final answer is going to be 2 robots, which this will cost us $20. Remember the NP/P is equals 10. And we have 3 workers since we went up till 3 workers. And this will cost us $15 because, again, this one's different. This one's $5 for the price. And then if we add them both, we maximize our budget, which is $35. And this is how the least cost rule is used, because it demonstrates how like the firms allocate resources efficiently to maximize the output, while however minimizing the costs. And yeah. Okay, so now we're going to talk about how the least cost rule and like the whole scenario kind of relates to what we talked about back in Unit 1 with the maximizing utility rule. So the reason why the skills are similar is because it's basically the same exact process of maximizing, except this time with maximizing utility, while buying 2 goods, they're maximizing the output while buying the 2 resources. So it's basically the same exact process, except the marginal utility optimal consumption rule is in regards to consumers, while the least cost rule is in regards to production. So we can go ahead and just do a quick little like example to show how similar both processes are, but it kind of differentiates because, again, like the least cost rule goes with production, and the marginal utility one goes with consumption. With consumers. So over here we can do the same exact chart. This is going to be for marginal utility. Okay, and we have number of times going. This is another example. So first, second, third, fourth. This is just gonna fill out the chart real quick. If there are marginal utility, which in this example it shows movies, and then we have marginal utility with, like, we can use go-karts as an example, and then this one, you can just put the same thing. You see, it's MP over price. Over here, it's just MU over P. So it's basically the same exact process. Okay, this price is going to be $5. This price is going to be $10. Again, same process. We have 3, 2, 1, 3, 2, 1. We have 50. It's the same exact thing as this one over here, actually. We have 2. Because again, this one. So it's the same process again. We have 10. 10 minus is 5. 5 divided by 10 divided by 5 is 2. We have this is 3 divided by 3. So we have 1, and then we have 0.40. And apparently to my calculator we have 0.20 because it's the same process. We just do 1 like divided by 1 like that. Okay. Okay, and then if you maximize it, again, we have to just go back and forth. So over here, it's 5, we use it once. Our budget is going to be $40 in this scenario. And if we keep going back and forth, we do this. This is 10. This is 10. It's 10. 5, 15, 25, 30, 10, 15, 25, 30, and then we have 40 down here, and that maximizes. So now we have over here, based on our results, we have 3 movies and 2 go-karts. So as you can see, it's literally the exact same process, except for this is using marginal utility over price for both to calculate the consumption rate. This over here is just basically calculating the production rate. So least cost rule and the marginal utility rule that we discussed back in unit like 1 or 2 is the same process, except it's just like allocating for different needs. Okay, so now we're just going to do a quick little example. So first we have, so the example says John hires workers at $13 an hour, and the marginal product of last year's worker is $70. He rents machines for $50 each, and the firm is at an optimal combination. What is the marginal product of the last machine used? Okay, so first we're going to use the least cost formula, like we discussed before with MP, marginal product price, MP over P. Again, it is just, this is the for least cost. So we need to use this formula to solve this problem. So let's go ahead and just fill out the formula with whatever the numbers we got from the problem. So it says John hires workers at $14 an hour. So that's going to be the marginal, it's going to be the price for the marginal product. So we're going to put down here 14. And it said that the marginal product of the last worker is $70. So that's going to be marginal product. Plug in 70. And then we're just going to, and then it says he rents machines for $50 each. So this is going to be for our next, our price for the next other marginal product. So this is going to be capital, because we discussed that this is like capital. So this represents $50 each. And then the only number that we aren't given yet is a marginal product for the machines. So now we just have to calculate this. Well, we know 70 divided by 14 is 5. Quickly just zoom in so you can see. Is 5. And then we have MP, sorry, to put the thing, Y over 50. So now we have to solve for this over here. 50 over here. And we have to just cancel out the numbers. So in order to cancel it, we just like times 50 both sides. And then 50 times 5 equals 250. So the marginal product of the last machine used is going to be $250. Or not dollars, sorry, just 250, because again the price was 50, and for that the marginal product for that is going to be 250 because of the formula that we had just calculated. Okay, so now we need to talk about, should John hire more workers, more machines, or not change his current labor and rental situation? So now we have to go ahead and just explain this based on our last problems. So right now we know that our wage rate is at $14, like we discussed before, and our marginal product of labor is 70. And then our rental rate for the machines are going to be at $50. This is 50. But in this scenario, it did say that $400. We're gonna scratch this off for the next problem because we were on number 4. So for this problem, it's asking if the last a marginal product of machines we used was 400. So not 250, 400 in a different problem. 400. Would he have to use more workers, more machines, or not change the rental rate and current labor and rental situation? So we're gonna go ahead and just plug in numbers once again. So we know we're gonna use the exact same formula that we had talked about before. So let's go ahead and plug in our numbers. So we have MP, P. So we already have we already have our 70, and we have our 14. This we already found that was 5. So now if we go to MP, we have to do this separately. Y. And now I have to plug in. Remember, 400 is our new number, not 250. Not 250. We found 250 for this one. 400, and then we have 50, and that equals 8. So since this one, the capital one, is more, because remember we got 8 for this one, the marginal product over the price is greater for the machines than it is for the workers. John gets more output per dollar for machines than he does for labor. Therefore, he should actually rent out more machines. And therefore, this adjustment will help balance the ratios and lower costs further. So just to summarize what we just did, again, we calculated both the numbers for the workers and the machines. And as you can see, the number for machines, we got 8. So the MP over P is greater than workers. Therefore, he should rent out more machines because it will give him more output per dollar, which is what he wants and what he's looking for. So that's pretty much it for all these problems, and this concludes 5.5.